In this video, I'm going to quickly go over the examples for quadrilaterals as well as parallelograms, and then I'm going to talk about squares and rectangles. So on the bottom of the quadrilaterals piece of the flipbook, you probably noticed these two problems where it talks about all quadrilaterals are going to be composed of. So in a quadrilateral, when you have four sides, those four sides together are going to make two triangles. This is helpful because we know that in two triangles, the interior angles of one triangle all have to add up to be 180 degrees. Well, if we have two of those, then we know in a quadrilateral, the inside angles are going to have to add up to be 360 degrees. So those two things are very important when we're talking about these quadrilaterals all the way through, because knowing that those interior angles are going to add up to be 360 degrees can help us figure out some missing measurements when we have that come up. So now let's talk about the examples that are on the bottom of the page for parallelograms. Okay, so just as a quick review, like parallelograms, we know that the opposite sides are congruent. We know that the opposite angles are congruent. We know the adjacent angles are supplementary. All of those properties we already know. So let's try to figure out in this parallelogram what the measurements are. So we're looking for what AD is. So I am marking AD, and then I'm looking for, because I know parallelograms, the opposite sides are congruent. So that means it's going to be congruent to BC. So if BC is 12 inches, then AD will also be 12 inches. Then we're asked to find what angle B is. So let me use a different color here. And angle B is going to be this angle right here. Well, we know that the opposite angles are congruent. So we know angle B is going to be congruent to angle D. Well, if angle D is 68 degrees, then angle B is going to be 68 degrees. So this next problem is a little bit more difficult. You're having to use those properties, but you're also having to say that this is congruent to this and solve it like algebraically. So the first thing that I'm going to notice is I'm going to see what it's asking for. So it's asking for what PR is. Well, PR is this diagonal here. That's the whole diagonal. Well, I know that my diagonals are congruent in a parallelogram, so I know that PR is going to be congruent to, well, I first need to figure out, in order to figure out what PR is, I've got to figure out what X is. Well, we also know that the diagonals inside of a parallelogram bisect each other. So we know that PT and RT, and let me use a different color to signify that. Let me use green. We know that PT is going to be congruent to RT. So we know those two things are equal to each other. So if we set them equal algebraically, we can figure out what our X is going to be, and that's going to help us to figure out what PR is. So X plus 9 is going to be equal to 4X minus 6. And now we're just going to solve for X. So I'm going to subtract X on both sides. I'm going to end up with 9 equals 3X minus 6. And I'm going to add that 6 over here. 3X equals 15. Divide both sides by 3. So my X equals 5. Well, that helps me figure out what PR is, because if I know that X is 5, then PT now becomes whatever 9 plus 5 is. So that's going to be 14. And then this should also be 14. So I know that PR together is going to be 14 and 14, which is going to be 28. So that was helpful in finding what PR was. Now we're looking for what QR is. Well, very similarly to what we just did, we actually are going to set, because QR is going to be equal to what PS is. Those two things are going to be equal to each other. So 2z plus 4 is going to be equal to 3z minus 4. And once we figure out that z, we can plug that in to see what, to either one of those to figure out what that's going to be. So I'm going to subtract 2z from the side. And I'll end up with 4 equals z minus 4. So add 4. Z is going to equal 8. Well, if z equals 8, I'm going to plug that back into QR to figure out what that is. So 3 times 8 minus 4. 3 times 8 is 24 minus 4, and that should be 20. So QR is now going to be 20. Okay, so those are the examples for parallelograms. Now we're going to move to talking about if I can find the rectangles, where did they go? Oh, here we are. Okay, so in a rectangle, you know a couple of things. You know that you have right angles in every angle of a rectangle. So all of those angles are congruent, also known as being right angles. So we know that they're 90 degrees. The thing about rectangles is we also know that they are parallelograms because they are going to follow all of the properties of a parallelogram. So it's really good here to go ahead and remind yourself of what those properties are. So for a parallelogram, we know that the opposite sides are congruent. We know that the diagonals are going to bisect each other. We know that the diagonals are going to be congruent. Etc. So it's going to follow the only difference in a rectangle. It is a type of parallelogram, so it's going to follow all the properties of a parallelogram, but it is also going to have 90-degree angles. So all of those properties that it followed for a parallelogram are going to be the same here, and then added that one property of all the angles being 90 degrees. Okay, so now that we know that about rectangles, let's also talk about squares. So properties of a square, you guys probably already know a lot of these, but you know that all the sides are going to be congruent. All 4 sides are congruent in a square. All the angles are going to be 90 degrees. So they are all going to be congruent. Squares are also a type of parallelogram. So just like before, they are going to follow all of those properties of parallelograms. The opposite sides being congruent, opposite angles being congruent, adjacent angles being supplementary, etc. Squares are also a type of rectangle. Squares are also going to be a type of rectangle. So they're going to follow all of the properties of a rectangle. And they're going to be parallelograms. They're going to be, squares are rectangles. And then squares are also what we call a rhombus. And you'll learn a little bit more about that later. But that are all the properties of squares and rectangles. And so now you'll have the ability to do the practice portions at the bottom of this. And then in my next video, I'll go over those practice portions.